Hello everyone, and welcome to part 4 of our free training series on multi-cloud infrastructure monitoring. Thank you for joining us today. Now here's what we'll cover today. First, we'll start with monitoring cloud application performance. You'll learn how to catch issues early and keep operations running smoothly. Next, we'll explore end-to-end visibility for serverless applications. This way, you can gain deeper insights into performance and identify areas for improvement. After that, we'll move on to tracking KPIs, which are key performance indicators, across container orchestration platforms and focus on how to detect and resolve performance issues before they escalate. And finally, we'll wrap up with strategies to address performance challenges and boost the efficiency of your entire cloud environment. Now, before we dive into today's topics, let's take a quick look at some industry facts. Right now, 24% of enterprises are already using the cloud. This means that cloud adoption isn't just an emerging trend anymore. It's the new standard. And the reasons are very clear. Businesses are migrating applications and infrastructure for scalability, flexibility, and cost efficiency. The growth ahead is staggering. The market is expected to hit $670 billion by 2025 and soar to $1.26 trillion by 2028. This kind of momentum comes with a challenge. To stay competitive, organizations must have robust IT structure, proactive monitoring, and unwavering performance and security. So why does monitoring matter? As businesses scale their cloud infrastructure, performance, security, and reliability, their challenges naturally grow. This is where cloud monitoring comes in. We can help you track key metrics, minimize downtime, and ensure that your resources are being used efficiently. In today's session, we'll show you exactly how to achieve all of this in a multi-cloud environment. Now let's talk about the cloud platforms we support. Enterprises today rely on a variety of cloud platforms to drive digital transformation and scale faster. Applications Manager supports monitoring for Amazon Web Services, Microsoft Azure, Oracle Cloud, Office 365, and Google Cloud Platform. These are all a part of our comprehensive monitoring bundles, giving you full visibility right out of the box. As you may already be aware, Applications Manager is an agentless monitoring tool that covers your entire IT infrastructure. This includes cloud applications. Now, instead of installing agents, we use APIs to pull data directly from your cloud resources. For example, with Azure, we use the Azure Monitor API, and the same goes with AWS Oracle Cloud. All this collected data flows into our fault management module, where it's analyzed to detect outages, performance issues, or high utilization. If something has gone wrong, we raise alarms so your team can act quickly. We use each cloud vendor's native SDKs for secure data collection, storing metrics for both real-time alerts and long-term analytics. Applications Manager integrates with services like AWS CloudWatch, Microsoft Azure, Google Cloud Platform, and Oracle Cloud to give you insights into compute instances, containers, databases, servers, and serverless components, all in one unified view. In Applications Manager, we monitor a wide range of AWS services to ensure seamless cloud operations. This includes AWS services of different categories, including compute, containers, security, databases, and much more. Now in this diagram, we illustrate how APM fetches key performance metrics using AWS SDK and API calls. For every different service, Applications Manager uses API calls such as describe instances for Elastic Compute Cloud, describe volumes for EBS, describe DB instances for relational database services, list buckets for simple storage service buckets, and list topics for SNS. Once we've gathered these details, we use the Get Metrics Statistics API to process the metrics collected from CloudWatch. This ensures efficient monitoring and enables proactive troubleshooting for all your AWS resources. So far, we've seen how Applications Manager monitors AWS services using the AWS SDK. Now let's shift our focus to Microsoft Azure. On this screen, you can see the supported Azure services, which are 48 in total. Just like with AWS, Applications Manager provides deep monitoring to ensure optimal performance and high availability across your Azure environment. Now let's talk about the discovery methods we use for Microsoft Azure. Since Applications Manager is agentless, we use 3 authentication modes to fetch Azure data. The first mode is Active Directory application. Here, you create an Active Directory application in the Azure portal and provide the client ID, tenant ID, and client secret. An API call generates an access token, which is then used to authenticate and retrieve monitoring data. The second mode is Azure Organizational Account. In this mode, you provide your Azure account credentials, which are your email and password. Applications Manager then automatically creates the AD application, retrieves its credentials via a PowerShell script, and uses the generated access token for authentication and data collection. The third mode is OAuth authentication. Now, this method uses open authorization with client credentials. It dynamically via the authorized and token endpoints, improving security by reducing credential exposure. These 3 methods give you complete flexibility in integrating with Azure while ensuring secure and reliable data collection. Now let's see how this works in the Applications Manager UI. Once you open the Applications Manager console, from the dashboard, click on New Monitor and then select Add New Monitor. Here, under the Cloud App section, you will be able to view Microsoft Azure. As mentioned before, you can view the 3 authentication modes to fetch your Azure data. Out of the 3 methods, we would recommend AD application and service principal. Go to the Add Microsoft Azure Monitor, you can view the pop-up here. So to add a new monitor, you will be asked to configure a few basic details. This includes the display name for easy identification, the subscription ID, which links the monitor to your Azure account, Azure services. Select the specific services to monitor. By default, all your services will be selected. Next, you will be asked to select your account type, your preferred account type. You can choose from Azure Global, which is a standard public cloud, the Azure Government Cloud, which is enhanced compliance for agencies, and Azure China, which is compliant with China's data regulations. You'll be asked to select a discovery mode. You can choose, as discussed earlier, we have 3 different modes. You can choose between AD application, OAuth, and the Azure organizational account. After that, you'll be asked to select between the child monitor discovery options. The first one discovers and unmanages all the child monitors. The second one, which is the default option, discovers and monitors all the child monitors. And the third one, this option, on selecting it, you will be able to discover and monitor the child monitors, matching the regex pattern provided in the below field. That is the discovery filtered regex field. Now the next option is the advanced setting option. You will receive a few more options. First, there's the Retry Data Collection API. Turn this on to automatically retry failed API requests so temporary issues like connectivity errors don't disrupt your monitoring. Next, alert on resource creation and deletion. Enabling this will notify you whenever a resource is added or removed to the Azure portal. Just a heads up, these alerts for deleted resources will continue until the monitor itself is removed. Finally, you can choose what to do with your deleted resources. There are 4 options in total. You can choose to continue alerting, which keeps deleted resources in the console and shows their alerts. Stop alerting leaves them in the console but stops affecting their health. Unmanaged resources stops monitoring them. And the delete resource option removes the monitor for anything deleted in Azure. After that, you will be asked to specify the timeout in seconds. The default value is 300 seconds. The discovery interval for child monitor discovery, the default of which is 5 minutes. And the polling interval, the default value of which is 5 minutes. Once you've entered all these values, you must use the test credentials option. This ensures that all entered credentials work before adding the monitor. Once you've entered all these details, you'll be able to successfully onboard your Microsoft Azure monitor. Now let's see what the onboarded monitor looks like in the UI. Once onboarded, the Azure Monitor dashboard in Applications Manager organizes key insights into specialized tabs. For example, the Overview tab gives you a consolidated view of all the Azure resources you're monitoring in Applications Manager. This is organized by category, as you can see here, such as Analytics, Containers, Compute, Databases, Integration, Security, Storage, and Networking. The purpose of the Overview tab is to help you quickly understand the breadth of your Azure environment, as displayed by the count of each monitor. Now, if you want to drill down into separate categories, simply select a specialized tab. For example, the Analytics tab. Now, this tab focuses on Azure Synapse Analytics and related data services. It displays details such as the workspace name, resource group, location, and the provisioning state. It also helps track health history for each workspace and enables alarm configuration, as you can see here, for downtime or performance drops. Now, the next tab is the Compute tab. Here, it lists out the Azure app service plans, the web apps, functions, virtual machines, and virtual machine scale sets. It also displays key details such as the location, OS type, usage, state, and the provisioning status. It also, similarly to the previous tab, supports alarms to monitor the availability, health, and changes in compute resources. Next is the Containers tab. Now, as you can see here, the Container tab lists the container apps, registries, and Kubernetes clusters. It also displays key details such as the resource group names, cluster locations, OS type, and the provisioning state. Similar to the previous tabs, it also supports alarms for resource failures or scale changes. Next, let's move on to the Databases tab. Now, this tab monitors services such as Cosmos DB, MariaDB, MySQL, PostgreSQL, and Redis Cache. It also displays the health status, provisioning state, query performance, and connection statistics similar to the previous tabs. Also view key details such as the location, tier, server type, and state of these monitors. On clicking on a separate monitor name, you can also choose to navigate directly to any resource type. for more detailed performance and health insights. Now, on the topic of databases, if you are interested in attending our upcoming webinar, Database Performance Decoded, from Bottlenecks to Breakthroughs, happening on September 11th, please take a moment to answer the poll that will appear on the screen. Let's talk about the next tab, which is the Integration tab. So this tab, similar to the previous one, tracks services such as Event Hub clusters, Event Hub namespaces, logic apps, relays, and service bus namespaces. It also displays key details such as the provisioning state, creation time, location, status, and SKU tier. Tab is especially useful for ensuring that Azure event-driven systems are functioning without delays. The Network tab offers a comprehensive view of all Azure networking components, which includes the application gateways, load balancers, firewalls, virtual networks, and express route circuits. Key benefits of monitoring this information is that it helps monitor traffic flow, latency, and security posture in real time, enabling a proactive network capacity planning. Next is the Security tab. Now, this tab helps monitor key vaults, manage HSMs. Using these monitors, you can track key rotations, secret expirations, and access policies. By monitoring all these key parameters, you can ensure encryption and secret management compliance. Now let's go to the Storage tab. This tab displays metrics for backup vaults, storage accounts, recovery service vaults, and storage sync services. These tables track standard metrics such as the storage capacity, latency, and replication status, along with the provisioning state. Let's move on to the Billing tab. This tab gives you a complete view of your Azure spending, including, as you can see here, the daily expenditure, which shows daily costs in a graphical format for trend analysis, the billing summary, which, as you can see, provides a current billing cycle details, including the start and end dates, and the total amount spent. Next is the top 10 costs by services, which breaks down which services are consuming the most amount of budget. Cost by resource group, which allows you to identify high-cost resource groups for optimization. Forecasting, which uses historical usage to predict upcoming costs for better financial planning. Along with alerting, which were present as usual in every tab to make sure that you can set alarms for budget overruns. For example, trigger alerts when monthly costs exceed a certain threshold. For example, here's a use case. To avoid any unexpected billing surprises and enable optimization of underutilized or idle resources, you can set a certain alarm to make sure you are alerted when a certain resource is underutilized and is going under your threshold. Now, in the Management tab, you can view subscription quota usage and available limits for Azure services. It also tracks client secret expiry dates for all your service principals in use. This tab ensures that teams renew credentials before they expire to prevent downtime, and also helps improve cost planning with its forecast spending. Let's talk about how Applications Manager monitors Microsoft 365 services. Microsoft 365 is one of the most widely used cloud-based productivity suites. So ensuring its availability and performance is critical for smooth business operations. With Applications Manager, you can monitor key Microsoft 365 services such as Exchange Online, SharePoint Online, and Microsoft Teams. We also proactively monitor user activity and license usage to help optimize costs and resource allocation. By tracking key metrics and generating real-time alerts, Applications Manager enables businesses to detect and resolve issues quickly and keeping productivity uninterrupted. Whether it's monitoring overall health and performance, analyzing Exchange mail service, tracking SharePoint sites, or checking Teams availability, Applications Manager gives you full visibility into your Microsoft 365 environment. Now let's move on to the next topic of the session, which is how to gain end-to-end visibility in your serverless application. But before we talk about serverless monitoring, let's see how application architecture has evolved. In the first monolithic model, the GUI, business logic, and database are all bundled into one large application. The problem? If you need to update or restart just one feature, you will have to restart the entire system, which causes downtime. Then came microservices, breaking applications into smaller independent services. Each service runs on its own and talks to others via APIs. This means you can make changes or fixes to one service without impacting the rest, allowing for faster updates and better scalability. And now we have serverless computing. You don't have to manage servers at all. The cloud provider runs your code on demand, scaling automatically and charging only for what you use. It's flexible, cost-efficient, and perfect for modern applications. But here's the problem. Serverless and microservice-based apps are harder to monitor. They're made up of many small components, so tracking performance, resource usage, and potential failures can get complex. This is where Applications Manager comes in. It collects data across all your serverless components, provides real-time insights, and raises alerts for issues, ensuring a smooth, uninterrupted operation. Now let's talk about serverless monitoring with AWS Lambda. Now in the real world, serverless often runs on event-driven architectures. In AWS, that means different Lambda functions handle specific tasks based on triggers. Applications Manager integrates with Amazon CloudWatch to collect and analyze performance metrics in real time. A few examples include inventory updates in DynamoDB when a purchase is made, order dispatches once all the conditions are met, and email notifications sent via AWS SES. Since Lambda functions can scale dynamically and run only when needed, it's crucial to track its performance, latency, and execution status. In practice, the monitoring process would work something like this. You upload your code to AWS Lambda. The platform automatically manages the infrastructure. You get a link to access your deployed application. And finally, Applications Manager tracks the KPIs, which includes execution time, errors, and throughput, so you know if everything's running smoothly. This ensures that your serverless workloads perform optimally without manual resource management. Now let's move on to the third topic of our day: tracking key performance indicators or KPIs across your container orchestration platforms. Containers have revolutionized the way applications are built, deployed, and managed. In Applications Manager, we provide monitoring for Docker, Kubernetes, OpenShift, and more, ensuring that your container environments are run smoothly and efficiently. Here's why this matters. Availability and performance. You can detect failing or slow containers before they impact users. You can scale efficiency to avoid over-provisioning and wasting resources. You can also choose to catch your problems before they appear and disappear in seconds. And maintain security by spotting vulnerabilities before they're exploited. And finally, you can track your cost optimization by tracking your usage so you're not paying for idle containers. This way, you can monitor CPU, memory, and network usage for every container, identify the ones that are using excessive resources, and get real-time alerts for failures or bottlenecks. This means you can even keep large-scale containerized environments running efficiently and cost-effectively. Now let's talk about OpenShift. In OpenShift, tracking the right KPIs is essential to keep workloads healthy and efficient. With Applications Manager, key metrics like node details, pod details, containers, services, and jobs are automatically monitored, giving you a complete view of performance and stability. Now, when it comes to discovering OpenShift in Applications Manager, we support two different methods. The first one is the SSH method with REST API support. Here, you establish an SSH connection to the OpenShift server, use the OC command to fetch details on nodes, pods, containers, services, and jobs. In the case of large-scale environments, we combine SSH with the REST API to avoid timeouts and ensure that all metrics are captured without delays. The second method to discover and monitor OpenShift is Prometheus integration. In this method, you integrate Prometheus with Applications Manager, fetch OpenShift metrics directly via the exposed Prometheus API, no SSH connection required. This method is especially useful in the case of secure environments, where direct SSH access is restricted. So by supporting both SSH and Prometheus methods, Applications Manager ensures that you can monitor OpenShift efficiently in any type of infrastructure. This balances performance visibility with your security requirements. Now let's take a look at how to add an OpenShift monitor in the UI. To start, adding OpenShift is simple. Just click on the Add New Monitor button, and under Virtualization, you will be able to find the different monitor options. So on clicking on OpenShift, you will be able to view the Add Monitor page. As mentioned in the previous Microsoft Azure Add Monitor page, you will be asked to enter a few basic details, including the display name, the cluster host name or the IP address, which is the host where the OpenShift is running. Next, you'll be asked to provide a username or password for the SSH access. You can also choose to select from the credential list. Next, we also have an option called Public Key Authentication, which is only supported for SSH version 2. If you select this option, you will simply need to provide the appropriate port number and the corresponding public key. Once these details are entered, Applications Manager will be able to collect key metrics using the REST API. Enabling this option allows you to gather the most important metrics available within your OpenShift environment, with data collection happening via the REST API instead of SSH. Next, you will be asked to enter a prompt value, which is the last character in your command prompt. Then the SSH port field, the default value of which is 22. After that, you will be asked to add your OpenShift username and password to connect with the cluster. And if you want to add key metrics via REST API, you will have to enable the collect major metrics using REST API option. When you do, you will also need to provide the WebSocket port, which defaults to 8443, and the service account token of your OpenShift cluster administrator. You can also monitor specific projects by enabling the Monitor Specific Projects option. Then choose a filter condition to either include or exclude certain projects and list the project names. You can enter multiple names separated by commas. After that, you'll be asked to enter the timeout value in seconds and the polling interval in minutes. Once you've set your preferences and saved them, the OpenShift monitor will appear in the Monitors tab. Now let's see what an onboarded monitor looks like in the UI. Similar to the Azure Monitor, different key performance indicators will be split into specialized tabs. Under the Overview tab, you can view the availability and performance history of your OpenShift cluster, along with its overall cluster usage details. For a specific cluster, you can choose to click on it, and which will display in-depth metrics such as the memory usage along with the historical trends. Similar to other monitor types, this section also lists basic details like the component information, the OpenShift summary details, the top 5 nodes used by pod count, and a breakdown of the component details. Next, in the project tab, you'll be able to see all the projects running on your container platform, along with their display name, their status, and the description, along with the created time. Next, in the Node tab, you'll be able to see the top 5 nodes based on CPU and memory usage, along with the top 5 nodes by memory details. Here, you can also find each node's name, host name, OS, and role displayed in table format. This is displayed despite the fact if it's a worker or master node, along with its creation time. You can also view the pod count, pod utilization, and the image count. Similar to the Node tab, the Pod tab also shows all pods with details such as the project name, the project IP, the pod IP, pod type, which can be either the replica, job, or controller, along with its status, start time, and the created time. Next, the Container tab highlights your top 5 containers by restart count, along with details such as the name, image, parent pod, status, and restart count, which is also displayed with the container start time and the restart count in tabular format. It is also displayed in graphical format for your understanding. In the Services tab, you will be able to see the details of all the services running in the cluster, compared with the type and cluster IP. You can also view key metrics such as the project name, the app, affiliated application, the service type, and the deployment details such as the project that is being deployed, the replica breakdown, deployment availability, and its overall health. You can also choose to configure alarms for the deployment details to ensure that you are alerted in case of any failure. The Replica tab lists all the replication controllers in the cluster, showing the name, project name, desired replica count, running replica count, and available replica count, along with the previous options to configure the health and the alarm status. It also includes details of all the replica sets in the cluster, showing the name, project name, desired replica, actions, and the health. In the Jobs tab, you can view all the currently scheduled jobs. This includes the project they belong to, the replica stats, which includes parallelism replica, desired, and the successful replica, affiliated actions, along with all the other configurable alarms option. Similarly, in the Jobs tab, you can view all the currently scheduled jobs, showing the project they belong to, the replica stats, as well as the start and completion types. And finally, in the Persistent Volume Claims tab, you can view all the PVCs in the cluster. It displays the project name, access mode, the storage class, status, name, the request in gigabytes, PVC capacity, and the creation time. Now, to display all these metrics behind the scene, Applications Manager connects to OpenShift via SSH and runs the OC command to pull all this data. With all this in place, you've got full visibility into your OpenShift environment. from top-level project health down to individual containers, helping you keep performance, stability, and security in check. Now let's move to the final topic of our webinar. So far, we've discussed how to track critical KPIs across your container orchestration platforms. Now let's shift our focus to something equally important, addressing performance issues and improving the efficiency of your cloud environment. With the right kind of strategies in place, you can optimize resource utilization, reduce latency, ensure applications run smoothly and cost efficiently. So first, let's talk about automating cloud operations. Now, when it comes to cloud environment monitoring, Applications Manager keeps a close eye on your applications and key parameters. If something goes down or a threshold is breached, an alarm is generated. From there, we have a few ways to respond. 1. Notify the right people through email or SMS. 2. Automatically log a ticket in Service Desk Plus or ServiceNow. Or 3. Take automated corrective actions without any sort of manual work. This is where automation really shines. For example, if a virtual machine in Azure or an EC2 instance in AWS unexpectedly goes down, Applications Manager can automatically restart it. There's no need for you to log in and do it. The same applies for containers. If a container's memory usage spikes, and you can set an automated action to shut it down or restart it. This means you can avoid manual intervention for routine recovery tasks, save time and reduce operational delays, keep critical systems available without waiting for human action. And this way, instead of manually managing hundreds of VMs or containers, Applications Manager does it for you, quickly, reliably, and automatically. Now, managing the cloud cost efficiently is just as important as optimizing performance. Cloud expenses can fluctuate significantly if not monitored properly, and this way they can exceed your budget. Within Applications Manager, you can stay informed about your cloud spending, track where you spend the most money, and identify cost-heavy services. This proactive approach helps you prevent cost overruns and gives you a better control over your financial aspects. While performance optimization ensures smooth operations, cost monitoring safeguards your budget, both of which are important for truly efficient cloud strategy. When it comes to the cloud, we need to make sure we are staying within the cloud cost limit allocated by our management. Applications Manager will help you track these expenses regularly by using the billing information for both Azure and AWS environments. With this, whenever the allocated budget goes beyond a particular limit, Applications Manager will send a notification to you or your management for the respective services. Next, let's talk about preventing service outages. Nobody wants unexpected outages. They cause downtime and impact users. To help you stay ahead, Applications Manager offers thresholds and alerts. You can set limits for things such as CPU or memory usage. If something goes beyond the limit, you will be notified instantly. Instead of manually restarting failed services, you can configure automatic actions. For example, if a cloud instance crashes, Applications Manager can restart it automatically. No need to log in and fix it yourself. This saves time and ensures smooth operations. Now, when you're running Applications Manager alongside your cloud applications, performance issues can sometimes be tricky to detect. This is where APM Insight steps in. Using the Service Map feature, you can get a clear view of all the components involved in your application, making it easier to track how services are interacting with one another, identify performance bottlenecks early on, and also resolve issues before they impact end users. Visual Map helps you speed up troubleshooting by showing you exactly where the slowdown or error originates. Now let's move to the UI to see how to automate actions in the cloud. In the Applications Manager UI, simply go to Actions on the dashboard. From this drop-down, select Cloud Actions. Now you will be asked to choose a platform. You can choose between Amazon and Azure EC2. With this, you will be asked to configure actions to start, stop, or restart VMs automatically when an instance either goes down or when utilization exceeds a certain limit. For example, if an EC2 instance goes down, Applications Manager can automatically restart it and send you an email notification. If this action fails, you will still be notified. You can even choose to schedule these actions for specific times as displayed here. You can also choose to execute an action based on business hours. Now, just like Cloud Actions, we also support container actions for OpenShift. As displayed in this dropdown, simply go to Container Actions. Now here, similarly to the Cloud Actions, you can choose to start, stop, or restart containers automatically if they happen to go down. In the case of Windows services, you can also choose to integrate with a REST API to perform these actions programmatically. Finally, let's take a quick look at our reporting feature. Navigate to Reports and go to the Cloud Apps section. Here, you can choose to select a type of service from this dropdown. And you can choose the report, such as availability report. Here, you can filter reports for any time range, ranging from today to the last 12 months. As you can see here today, you can filter out any time range as per your preference. This helps you track trends, uptime, and performance history. Now, before we wrap up, let's quickly go over what we covered today. First, we looked at how to proactively monitor your AWS cloud applications. This helps you track performance metrics, detect slowdowns, and ensure smooth operations. Next, we explored how to keep track of your Azure applications. By doing so, you can gain insights into your performance, optimize resources, and improve efficiency. We also talked about tracking critical KPIs for container orchestration, whether you're using Kubernetes or other platforms. Monitoring these KPIs helps you spot issues early and take corrective actions before they escalate. And finally, we talked about how to pinpoint performance bottlenecks in your cloud environment. Continuous monitoring allows you to detect slowdowns, troubleshoot problems, and identify areas where performance improvements are possible. With these capabilities, you will be able to have better visibility and control over your cloud applications, ensuring optimal performance and reliability. I hope this session gave you some sort of valuable insight to take away. Thank you all for joining us today.